I'm going to read this worksheet with you, and if you want to, you can skip ahead to just hear me explain the problems at the end. But I will start by reading out loud. 8.5, Isotope Notes and Practice, Chunk and Chew. In Lesson 1, we were reminded that the number of protons identifies an atom. For example, an atom with 6 protons is carbon. All carbon atoms have 6 protons. If an atom has a different number of protons, then it isn't carbon. So we see how the 6 protons matches the atomic number of carbon. An atom with 92 protons must be uranium. 1 proton is always hydrogen. Reading on. You also learned that the nucleus of atoms contains protons and neutrons. Question: do all atoms of carbon, for example, have the same number of neutrons? The answer is no. When an element's atoms have different numbers of neutrons, they are said to be isotopes of that element. So here in the box is a definition. Isotopes are atoms of the same element, same protons, with different numbers of neutrons and therefore different masses. The word isotope is new, so at first this seems difficult. However, an analogy can help us understand. Identical twins or triplets are a good analogy for isotopes. They have the same DNA, like being the same element, and yet they may have different feelings, different abilities, different weights or masses, etc. So here are 3 triplets that have a lot of things in common. They're the same DNA, but they also have some differences. Apples are another analogy for isotopes. The 3 fruits shown are all apples, and yet there are some differences. They could be considered isotopes of each other. They might be used in different ways. Apple A is a Honeycrisp apple, crisp with balanced flavor, tart and sweet, great for eating plain. Apple B is a Haralson apple, tart with good apple flavor, great for baking in pies. Apple C is a Granny Smith apple, very tart and hard texture with thick skin, great to mix with sweeter apples when baking. Next is a video. To play, click the link, then select Open in Safari. Do a split screen to watch the video. Pause and answer the questions as you go, or answer at the end. If you can't open the video through Notability, you can go back to Schoology Week 8, Lesson 2, and it is embedded in this assignment 8.5. So I'll click here for the video, and you see that Open in Safari note. And if I do that, I should be able to watch the video and do a split screen to see the questions. I'll let you watch that. If you want to pause and do that now, you can. Otherwise, I will go on. I'm going to just read the questions out loud here. Number 1, what are isotopes? 2, what elements do the models represent? 3, how many protons does carbon-12 have? 4, how many protons does carbon-13 have? 5, how many protons does carbon-14 have? 6, what particle makes a carbon atom a carbon atom? All 3 atoms have the same number of these. 7, the 3 models of carbon are, 8, what is the 12 in carbon-12? 9, what is an isotope? 10, how many protons does calcium have? Going on, here's where you do some practice. I'll read the directions and do one example from each section. Chew. Draw lines to connect each atom on side A with its isotope on side B. Remember, focus on the nucleus and think about what is the same about 2 isotopes and what is different. We have many ways to draw atoms, so don't be distracted by the colors or electrons. So I have 3 atoms on side A and 3 on side B, and I'm going to connect them with a line to show which are isotopes with each other. We need to know the definition of isotope to do this. So I'm reading in the yellow box again. Isotopes are atoms of the same element, same protons, with different numbers of neutrons, and therefore different masses. Same protons, different neutrons. So when I look at this atom A over here, I see 8 protons, 8p, 10n, 8 protons, 10 neutrons. So I need to find one on the other side that has 8p, but a different number of neutrons. Don't get confused when you see here protons are 10. Remember over here it was protons are 8. Have you figured out which one it is? If you said this one, then you're right. The protons are the same, 8, but the neutrons are different. You can pause here and try the rest, and then we'll go to the next section. In this section, it says you try it. Fill in the nucleus to make a possible isotope for each of the following atoms. I see the periodic table square for aluminum, and I see an aluminum isotope A here with 13 protons and 14 neutrons. Remember, the 13 matches the atomic number. And all aluminum atoms always have 13 protons. So I'm going to put 13 here. Now this atom in the A side again has 14 neutrons. And incidentally, 13 plus 14 is 27, and that gives you the mass. That's a little more than the average mass here of 26.9. But some atoms of aluminum have a different number of neutrons. Now you might pick any number then that's different than 14, but usually they have a similar number, so I'm going to put 15 neutrons. All right, good luck finishing the worksheet and then submit it to Schoology 8.5 Isotope Notes and Practice.